see the algorithm that how this mutual exclusion is achieved. Means how at a time only one process is able to enter in the CPU and other process are prevented to enter or utilizing the CPU. So that process will enter into the ready queue only, and that can enter into the critical section, or that can use the CPU only when the first process it will finish its job. So it is achieved by using one hardware algorithm. That algorithm is called as test and set lock algorithm, which provides the hardware support. Means here when the process P1, let us consider that 10 processes are there, and if process P1 it is entered into the CPU, if it is currently utilizing the CPU, then your hardware it generates the interrupt. So it generates the interrupt in terms of values, that is in terms of 0 and 1. And when that interrupt is generated, then other processes are prevented from using the CPU. Okay, so this is called as test and set lock. So test and set lock, it is a synchronization mechanism by using which the different processes are synchronized, and it uses the test and set instruction to provide the synchronization among the processes which are executing concurrently. Now how it is achieved? So now see, this is the code which is used by the test and set lock hardware support algorithm. So here you can see that now suppose if process want to use the critical section. So if process is used want to enter into the critical section, then it should execute the entry section which is written for this TSL algorithm, and once its execution is completed, then it should execute the exit section which is written for this algorithm. And this program it is written in the assembly level language. So by using the assembly level language, this line we can directly interact with the hardware, or we can directly interact with the machine parts of the system. So here while condition is there, this condition it is set for this test and set log. So log, this is the flag which is set by this algorithm. Okay, so let us consider that two processes are there and that want to execute the critical section. So here initially the lock value, that is flag value, it is set to 0 because it uses only two values, 0 and 1. So initially the value of the lock it is set to 0. Now what is the meaning of 0? So if value of the lock is equal to 0, it means that the critical section is currently vacant. That is, no process is utilizing the CPU. Currently this section is empty. If value of the flag is equal to 0, so this value it is set by this TSL algorithm. And if value lock value is, if it is equal to 1, its meaning is that critical section is currently occupied, that is currently some of the process there which is utilizing this CPU or this critical section, and means here, and that time when that process will enter into the critical section, that time your algorithm it will change the value of the log from 0 to 1. Its meaning is that process is present inside the critical region. So now we will see this algorithm by taking one example. So let us consider this algorithm. So initially consider that the value lock value or flag value it is equal to 0. That is, no process is currently utilizing the critical section, or no process is present in the run state. Okay. Now here let us consider that process P0 it arrives in the ready queue. No other process is there which is present in the run state, and process P0 it arrives in the ready queue. So now what it will do? So this process, so now here we are implementing this algorithm, that how the mutual exclusion is achieved by using the test and set lock algorithm. So it executes the test and set lock instruction. So it will execute this while loop, and here it will check the value of the lock. So initially the value of the lock it is equal to 0. So here since lock value is set to 0, so it returns value 0 to the while loop. At first it will check the value of the log, it is equal to 0. So it returns that value 0 to the while loop and sets that log value equal to 1. So it changed the value of the log. And then when it returned the value 0 to the while loop, your TSL algorithm or this hardware support algorithm, it break the while loop condition, and then process P0 it enters into the critical section and it executes. Okay. After that, now if the process P0 it gets preempted in the middle, means now let us consider that process P0 it is utilizing the CPU time, it is executing, and now if it requires the input output operation, that is suppose it want to read the data from the file which is saved onto the secondary disk or onto the hard disk. So in that case, the process P0, it will get preempted from the run state and it will get entered into the wait and block state. So currently your CPU is free. No other process is utilizing that CPU. Why no other process can't use this CPU? Because here when the process it enters into the critical section, so before entering it into the critical section, it has to execute the entry section code. That is, it has to check the value of the log. So now if the process P0 it is shifted from run state into the block state and process P1 it want to enter into the critical section, it will check the value of the log, and as the value of the log is equal to 1, the process P1 it is not able to enter into the critical section, though the process P0 is not utilizing the CPU. Okay, so that process P1 it can enter into the critical section only when value of the log is equal to 0, and only when this process P0 it will come out from the critical section and it will set the value of the log equal to 0, or when it will execute the exit section code which is written for this TSL algorithm. Okay, so now let us consider that another process P1 arrives. So it executes the test and set log instruction, and here it will check the value of the log. So here value of the log is equal to 1. So it returns value 1 to the while loop and sets the log value to 1. Because here value of log is equal to 1, so here because of this it returns that value to the while loop and it is not able to enter into the critical section. So the return value 1, as the value 1 is returned to the while loop, because of this it cannot break the while loop condition and it is not able to enter into the critical section. So here the process P1 it is trapped inside an infinite while loop. Okay, and the while loop keeps the process P1 busy until the log value becomes 0, and it can allow the process P1 to enter into the critical section only when value of the log it is equal to 0. Okay, so now let us consider that in the case 3, process P0 it comes out of the critical section. So when it will come out of the critical section, it has to execute this exit section code. So in that case, what it will do, it will change the value of the log from 1 to 0. Okay, so the while loop condition breaks. So here because of this while loop condition is break for the process P1, and in that case now process P1 which was waiting for the critical section, now it can enter into the critical section. So now even if process P1 gets preempted in the middle, no other process can enter into the critical section. That is, now the value of the log it is equal to 1, process P1 is utilizing the CPU. If it requires the input output resources, then it enters into the block and wait state. But though no process is there into the critical section, another process is not able to enter into the critical section because value of the log it is equal to 1. That is, process can enter into the critical section only when the value of the log is equal to 0, and if the value of the log is equal to 1, no other process can enter into the critical section. So what are the advantages of the TSL algorithm? So it ensures mutual exclusion, because at a time though multiple processes are there in the ready queue, only one process it can enter into the critical section, and it is deadlock free. Deadlock never occur there because only one process is utilizing the CPU, only one process is entered, can enter into the block and wait state for the input output resources. So because of this, deadlock never occurred when you are using the TSL algorithm, but it does not guarantee bounded waiting and it may cause starvation. Now, what is the meaning of bounded waiting? So it does not guarantee bounded waiting. Its meaning is that each process must have a limited waiting time, and it should not wait endlessly into the ready queue. Okay, but here it does not guarantee bounded waiting, because अगर process P0 critical section use कर रही है and if it is waiting for the input output resource, then that time suppose it is waiting, that process it is blocked because of the some reason, or if that process it is failed inside the CPU or inside the critical section only, then other process that have to wait for unlimited time amount into the ready queue. Because of this, it does not guarantee the bounded waiting. And it is a busy waiting solution which keeps the CPU busy, because CPU it is always busy. Though the process is currently utilizing the CPU, that time the value of the log it is equal to 1. And if other process will try to enter into the critical section, that time CPU it will not allow the other process to enter into the CPU. So always the CPU is busy in checking the value of the log.